Hey, it's Dr. Boessenecker here. It's both Fossil Friday and Shark Week, so let's take a deep dive into some research published by our recently graduated research student, Addison Miller. Many modern sharks give live birth, and they tend to be rather small and vulnerable to predators, i.e., often other sharks. So many, like black tip reef sharks here, tend to give birth in shallow marine embayments like lagoons. Bulls Bay in South Carolina, just a few miles up the coast, hosts several different species of sharks that routinely give birth in that shallow embayment. These embayments are rich in fish, low in predators, and sharks can grow to larger sizes before venturing out into the open ocean. Carolina low country, after all, is low. Fossils are buried, so we generally need some sort of artificial exposure in order to find them. This is a construction site showing three different rock units. The Ashley Formation, which is about 28 to 30 million years old from the early Oligocene epoch, and the Chandler Bridge Formation, which is from the late Oligocene, roughly 23 to 25 million years old. On top of that is the Pleistocene 10-mile hill formation. While this also yields fossils, we're not really going to be talking about those. We're mostly focused on the Oligocene rocks here. These have produced many fossil sea turtles, gigantic killer dolphins, giant bony-toothed birds, early baleen whales that still had teeth, a bunch of other dolphins, as well as, of course, sharks. In May and June of 2018, I got access to this stormwater retention pond at what is now a fully constructed subdivision. It was very hot, so I tended to bring out a golf umbrella and just dig at this bone bed. And after not a whole lot of looking, I started finding teeth of Carcharicles angustidens, shown here. Now, to put this species, Carcharicles angustidens, into context, it is from one of many different sedimentary rock units in the South Carolina coastal plain. So here we have rocks from oldest to youngest, oldest at the bottom, youngest at the top. So we got the Williamsburg, which is just after the extinction of the dinosaurs, and then the Ashley and Chandler Bridge is right there in the middle. So if we look, we get Otodus obliquus, evolving right after the extinction of the dinosaurs. These teeth are unserrated, and they are quite large, but they are dwarfed by later species in this lineage. The next is Carcharicles auriculatus, which is the first serrated megatoothed shark. It's not much bigger than Otodus obliquus, though. After that, we get Carcharicles angustidens, which is the species I had just found in the Chandler Bridge and Ashley formations. Above that is Carcharicles chibatensis, which is quite a bit larger. And then, of course, the famous monster herself, Carcharicles megalodon, found in younger Miocene and Pliocene rocks in the southeastern U.S. and worldwide. I made it over to this other pond, shown here, and the Ashley is that white stripe at the bottom, and the orange and brown and grays above that is the Chandler Bridge Formation. One day in particular, I found this tooth, and then another, and another, and another, and eventually, by the end of the day, I had found all of these teeth. Actually, I found all of these in about 25 minutes, which is a shocking number of teeth, and they are all little. You can see the beer bottle cap there for scale. After bringing all of these specimens back to the museum and getting them cataloged, I realized we had about 30 or so teeth, and I started thinking this would be a great student research project. Measure these teeth. Seems to be dominated by juveniles, possibly evidence of a shark nursery. So my student Addie and I made it over to Charleston Museum, and we investigated a second set of teeth. These are all specimens collected from an excavation of the original exposure of the Chandler Bridge Formation only a couple miles away. There's the excavation on the lower left. It was done in a grid. Every single tooth has a position in the quarry, all found under controlled excavation. So we found all these teeth. Great. What's next? How do we actually scientifically investigate whether or not this represents a nursery assemblage from the Chandler Bridge Formation? Well, Addie here was tasked with identifying every single tooth to position. Now, this tooth jaw layout here on the upper left is based on specimen from the Oligocene of New Zealand. So the species Angustidens live worldwide. My PhD advisor found this specimen in the 90s and cut it out of a limestone cliff using a chainsaw. Thanks to his research, we were able to identify every single tooth to position. The next step is using tooth-specific linear regression equations and plug in the length of each tooth, which spits out a total length of the shark based upon published measurements of shark teeth and body length for the modern great white shark. When you do this, you end up with this data set. So this is all 130 teeth or so from the Chandler Bridge Formation. Neonates, like baby sharks, we only had a few of them. Those are the blue. Juveniles are in yellow, and adults are in red. So there's only a few adults. Most of the adults are only slightly larger than the largest juveniles. This is a histogram, so most of the sharks are between 4 and 5 meters long. So on the bottom of the chart, that is how long the shark is. And then on the left, i.e. the y-axis, that's the number of teeth for that size bin. So 31 sharks were 4 to 4.5 meters long. 117 out of 127 sharks were reconstructed as juveniles, and there were 2 adults that were approaching 11 meters. So most sharks roughly between 3 and 7 meters long. So Addie went ahead and wrote all this up, and we got this published with our colleague Matt Gibson over at the Charleston Museum. We got this published in the journal Paleontologia Electronica just a couple months ago. A megatoothed shark, Curator angustidens nursery in the Oligocene Charleston Embayment, South Carolina, USA. So lastly, I would like to congratulate Addie on getting this spectacular piece of research published, and of course, congratulations on graduating and getting a job in the geosciences. And thanks for watching.